Hello everybody. I would like to show you some interesting aspect of the impedance today. Last time we talked about the impedance in part 4 of the lecture number 2. We talked about the impedance of capacitance. So we have the capacitance 1 over j omega c has the impedance. That means the impedance is inversely proportional to the angular frequency. For the inductance impedance Z sub L, that's proportional to the angular frequency omega. If you have combination with the devices, the elements, let's see if I have, excuse me, if we have the series connected, the L and C, the combination of the impedance I apply here, so that will be 1 is j omega L plus 1 over j omega C. And if you see the magnitude of this impedance, actually it drops very low at a certain frequency, right? This frequency corresponds to about 31 kilo radian per second. We calculate, if I use the parameters here, I have 10 microfarad capacitance and 100 microhenry inductance. So this point is called the resonance. At this resonance, what the impedance, ideally is 0, right? So what if you apply the voltage? So the current is going to be huge, and the voltage across each element is going to be huge as well, right? In the real world, it doesn't happen that dramatic, but we will see some of the effect here. So I would like to observe if we can use a simple LC circuit. In front of me, I have this setup here. I have the so this one here, this is the 10 microfarad capacitance. This inductance is 100 microhenry. By the way, 1006 means 10 to the power 6 picofarad, which is 10 microfarads. And I use the waveform generator that I apply. So this yellow line and black line that's coming from the waveform generator that will give me the AC signal or the sinusoidal signal applied to the two ends of the connected, so that connected L and C. So that's the total voltage across L and C. And I use the channel, this is the scope, I use the channel 1 to measure the total voltage. And I use the channel 2 to measure the voltage just across the capacitance, okay, the two orange lines. So that's the setup. And if you look at the schematic here, I have a schematic. Basically, I have a function generator applied the sinusoidal voltage across this series connected L and C, and I measure the voltage across the capacitor and measure the voltage across the total, because the function generator, the total 1 volt, maybe the actual is not. Okay, so let me turn off this camera here and go to the waveform generator. Okay. Right now, what I'm having here is I have waveform generator. I'm generating 2 kilohertz. So I'm generating 2 kilohertz. That's not at the resonant frequency, right? The resonant frequency is about 5 kilohertz, exactly the 5033 hertz. So in this case, we have 2 kilohertz, and let's see the voltage. Right? The voltage, I use the scope. So the scope voltage is, remember the channel 2 is for the capacitor voltage. So the capacitor voltage actually slightly higher than the total voltage across the L and C, right? So that's actually the resonance started happening there. And at right at that frequency, the resonant frequency, let's see if I can change this resonant frequency to 5.033. In that case, so I'm still having, so now the frequency changed to, if you look at the scale here, the 200 micro 200 microseconds. Total the period is slightly less than 200 microseconds. So that's a 5 or a little bit higher than 5 kilohertz. So let's see the waveform. Are you expecting very interesting the effect there? Ooh, look at it, right? So the voltage across this total voltage, the blue, that's channel 1, right? The total voltage very small compared to the voltage across the capacitor. That's the resonance, because the combined impedance is very small, right? So therefore the current is very large, so the voltage across the capacitance will be higher than the voltage across the total, and the voltage across the inductance is also going to be higher than this. So I'm not going to be able to measure, so I only have 2 channels. But you will see the effect. One interesting aspect here is you see the total voltage here. I have 100 I have both channels at 100 millivolts per division. That's a very small voltage, right? Although the wave generator claims to have the 1 volt output, but it couldn't maintain that 1 volt because the current, the impedance is too small, almost short-circuited the output from the wave generator. So therefore, there you have it. That's the resonance happening right in front of you. Okay, I hope you enjoyed this video, and until next video, I'll see you next time. Bye bye, folks.